Now for our examples, you want to state which theorem you could use to show that the quadrilateral is a parallelogram. So just follow along with me, possibly have your notes handy so you can see which theorem you're going to use. But on number one, a theorem that you could use to prove that this quadrilateral is a parallelogram, we have one pair of opposite sides. They're parallel, shown by the arrows here. They're both A units in length, so they are congruent. You would specifically use on that one the opposite sides parallel and congruent theorem. Number two, maybe you were taking a look at that while I was writing down what theorem you could use. If you notice, the opposite angles of the quadrilateral are congruent. One pair of opposite angles are 61 degrees. Other pair are 119 degrees. So it would be the parallelogram opposite angles converse. Don't forget the key word there, converse. If you just wrote the parallelogram opposite angles theorem, that would not be correct. So we're trying to show or prove that this quadrilateral is a parallelogram. And then number three would be the parallelogram diagonals, again, converse. And then number four, it says find the values of x and y that make the quadrilateral a parallelogram. In order for that quadrilateral to be a parallelogram, opposite angles have to be congruent. So you can set up a couple of equations there. I'm actually going to skip number four because there's some information that's missing there. The equations that you could set up, 3x minus 20 is equal to 4y. You wouldn't be able to solve that without a second equation. These two angles should be congruent as well, but nothing's given here. So I'm going to kind of skip that one for now and then go to number five. So on number five, to be able to find the values of x and y, you actually want to use a parallelogram diagonals converse. The diagonals have to bisect each other. So 6x has to be equal to 4x plus 10. You could solve that equation. And then 2y has to equal y plus 1. And we could solve that equation as well. For the first equation, if you subtract 4x from each side, 2x is equal to 10. If you divide each side by 2, then x is equal to 5. Solving the second equation, you just have to subtract y from each side. Y is equal to 1. All right, and then on number 6, once you could actually see the problem, to find the values of x and y, opposite angles have to be congruent. So y has to equal 106 degrees. That's already solved. And then opposite sides have to be parallel, which they are, and congruent. So 10x is equal to 12x minus 9. And then you could solve this for x. Subtract 12x from each side. 10x minus 12x is negative 2x equals negative 9. If you divide each side by negative 2x is equal to, there's the work that you can see now. Negative 9 divided by negative 2 is 4.5.